times n grid. Each tile one is where you start. Two is where you stop. Zero, empty square you can walk over. So the white ones, and -1 are the obstacles. Yeah, so hmm, I guess you can brute force this. Just depth for search, and the path has to be the same length as the number of white squares. Yeah, I mean, yeah, start with the brute force. I don't really know if there's a better way of doing this. So the first pass would be basically looking for where the start is, and also counting the number of white squares. So I guess I'll make it global because I know I'll have a depth for search under. So this one will be uh one, I guess. Start at 0. So then I'm trying to look for the starting position. So starting position is going to be an array of size 2, where the first one is going to be the I, second one is the J. And now I'm iterating through the matrix to find these values. So then the value is going to be grid at IJ. So then there's the case where the value is equal to 1. And then we're going to be setting start. Uh, 0 is going to be I. Start 1 with J. So the value is 0. Those are the empty squares. Yeah, so then path length is going to increment every time we see 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9. Oh, the path length, well, to get there is going to be 10. Guess we can make it start at 1, I guess. Yeah, something like that. I'll make it 0 for now, see if I need to change it later. So this is just setup. After that, I want for search. So I think I'd have the row, column, grid, and that's basically, no, I also need a set, but I could also make that global because it just makes it easier. And here, the hash set is going to have to contain the positioning. I can make it a string that has the x and y. I think that's probably easiest. Yeah. Mm, yeah, because if I make it a hash set, I can check the length. But instead I could also have a path length as a parameter. Yeah. So I guess I could have like a visited array instead, a visited matrix. That's probably gonna take less memory. I mean, uh, yeah, it's just do. And this, you can only notice size once we're inside the unique path. So it's a 2D. So it's gonna be the length dimensions as the grid. And this is gonna keep track of where we have visited already. Oh, to make things easier, I could just make it so that uh, the yeah, I can make the tiles that are red, set them as visited already, so that I never pass them. So I can make the start already visited. No, I'll just make it visited first time I pass because else it's gonna screw me over later. It's not, it's -1 that we can't fall forward. Yeah, something like that. So now I kind of want to do this where the row is going to be start at 0. I'm going to start at 1. The grid is the grid. And I want to return. Yeah, so I'll have another variable as the answer. I start at 0. And this is what I'll increment it inside the BFS. Yeah. Oh, and also I have a path length at the beginning, so it's a 0. So that would be otherwise, I guess. So I guess if the length is equal to uh equal to the path length and the current tile or not, so I just put that below and tell them. Oh, there's two cases. Oh wait, no, because then I would have traveled everywhere and I should have landed there. So mm, yeah. Let me see, I've set by 1 because I need to travel at least once to get to the flag. So if the length is equal to the path length, then I can increment answer by 1. I also have to travel. So then I want to go basically top, right, bottom, left, for the top. I can't do it if the column is less than 0, but it's greater than 0. Then I should be able to go to the top. And also I should do a visited check. So If visited column, I just return, so I give up on that path. Yeah. Whenever I'm somewhere, I need to declare that visited already. So row and column is going to be set to be normal. And then at the end, when I write everything else, and I can set the row and column as so it's not visited anymore. Yeah. So then if I want to go to the top, I want to EFS at row -1, same column, same grid, the length increased by 1. I can go to the right if the wait, no, that's not the column, that's the row that has to be greater than 0. So to the right, I need the column to be less than the grids at length. Then to go to the right, wait, it has to be strictly greater than 1. Right? Yeah, so I can go to row 0. So I can only go to the right if I'm at the one before. Yeah, because if I'm at the last one, I can't go right anymore. Then same row, n plus 1. So grid, the length increases by 1. Down with the row is less than its length -1. Go down, column, grid, length increases by 1. I want to go left. Can only do it if column greater than 0. Hmm, there should be something like that. If column is greater than 0, then I can go left. -1, so good, like by 1. Yeah, so that should trouble everywhere. If it's visited, then give up. Yeah, but 9. Oh, oh wait, okay, no, because the length I increment by 1, but the DP should keep track of it. I'm overestimating. Am I like revisiting twice the same paths? Uh, what if I put this to 0? Is that the reason why? Oh wait, I know why. It's because I'm visiting the yeah, I'm visiting the flag too early. I'm just checking how many times I can fill the grid. So I shouldn't be visiting. Yeah. So if it's not equal to path length, so if I'm at the flags, if grid at row and column equal to 2, and then the length is not equal to the path length, so I haven't reached the end yet, then that means I should give up. It's not good to visit T flag too early. There we go. Are you gonna get TLD? Oh, puggers.